Let's go back to our grades scenario. Arrays can hold different data types. This one will be of type int since it will hold grades. We can create an array with the student's name that holds 15 grades. Here's what it will look like. Int, square brackets, student underscore name equals new int, square brackets with 15 in the middle. This array is declared and initialized to hold 15 elements. However, all the elements are currently empty. This is because arrays are null by default. So here is a visual of what our array currently looks like. We now need to fill our array with grades. Let's say the first 3 grades of the marking period are done and we want to input them into our array. We could do that using this code. Lines 2 through 4 fill the first 3 elements of the array with the grades 95, 92, and 87. Notice that the first position of an array starts with an index value of 0. This means that for our array with 15 elements, the position will go from student name 0 to student name 14. So the index here is 0, and the index of this last box is 14. You can also assign values to elements when you declare an array. When filling an array in this way, new is no longer required, but the array will only have as many elements as listed. So here, this array will have 3 grades in it. Int, student name equals, curly braces, 95, 92, 87. This gives us the ability to simplify code. What once took 4 lines of code is now done in 1. However, the length of array student name is 3, and you cannot subsequently add more grades. For example, adding student name 3 equals 98 will produce an error because index 3 does not exist. If we attempt to access an array element out of range, an error will occur and this can terminate the program. For example, this will produce a Java out of bounds and array index out of bounds exception in your IDE compiler window because an element space does not exist at student name 30. Remember, an array with 30 compartments will only go up to an index of 29, since indexes start at 0 rather than 1.